In this section, we're going to try and find unknown values of the parameters of a normal distribution. So far you've always been given both of the parameters and you've been asked to find a probability. This time we're going to go work in reverse. We've been given a probability and we're asked to find one or more of the parameters. So let's just get an idea of what's happening here in terms of our x variable. So this is, think about the x distribution here. So our x distribution has mean mu and variance 9. So we know that mu is in the centre, and we're told that the probability of x being greater than 20 is 0.2. So I know that that 20 must be to the right of my mean, and that area there is 0.2. The reason why I know 20 must be to the right of mu is because if it was to the left of mu and I shaded into the right of 20, then I would have more than half of the distribution, which would be more than 0.5. So we can't solve this problem at the moment, but what we're going to do to solve this problem is we're always going to standardize. So remember, standardizing means get this probability statement, turn it from a statement about x to a statement about z. And here z is going to be our random variable, and to standardize it we're going to take our random variable x, we're going to take away its mean, which is mu, and divide by the standard deviation of this random variable, which is 3. And we know in this case z, when we standardize, always follows a normal distribution 0, 1, that's standard normal variable. So let's take our probability statement to do with x and try and transform it into a statement to do with z. So we're going to do the same thing to both sides of this inequality to try and get this expression on the left hand side. So we're going to take away mu from both sides of the inequality, and we're going to divide both sides of the inequality by 3, the standard deviation. And because we've done the same thing to both sides of the inequality, this statement here is exactly the same as this probability here. So the reason why we've done that is because on the left hand side, this random variable here is our standard normal random variable, and we know that this is true. So we've now got a problem to do with our standard normal variable z. So let's draw a sketch of our z distribution here. So this is a sketch of z which follows a normal 0, 1 distribution. So we've got z values now along the x-axis. So what this statement here says is it says the probability of z being to the right of 20 minus mu over 3, so z being bigger than that, is 0.2. So we know that there must be some value where to the right of that value the probability is 0.2, and that value is 20 minus mu over 3, that whole expression here. Well, we can use our calculators to work out what this value is by using inverse normal. So if we go to our calculators and we go on distribution, normal, inverse normal, we want the right of our unknown value has an area of 0.2, and because we're working with z now, we know that the mean is 0 and the standard deviation is 1. So I've already put that in, 1 and 0. And then we can find out that that value is 0.842 to 3 sig fig. So we know that this value here must be 0.842. So we can put those two things equal to each other to find out what mu is. So we know that 20 minus mu over 3 is 0.842. And we can find mu and find out what it is by solving this equation. So 20 minus mu is 2.524, and so mu is 17.5 to 3 sig fig.